Good morning, students. Shinde sir here. Once again, we have to continue the topic similarity. I think you are familiar with the properties related with the ratio of areas of two triangles. Now, three aspects we have already considered with different base and height point of view. That ratio of areas of two triangles is equals to the ratio of product of base and corresponding height. Next and second property, triangles of equal base have areas proportional to their corresponding heights. Third one, triangles of equal height have areas proportional to their corresponding bases. So depends upon that, we have to just consider the practice set 1.1. So first example, look into that given information. Base of triangle is 9 and height is 5. Means first one triangle you can consider. So for that, base it is given 9 and height it is 5. So base of another triangle is 10 and the respective height it is 6. So as we observe that given measures, then definitely base as well as height it is different for both the triangles. So what we have to calculate? Find the ratio of areas of these triangles. So we can consider let B1 H1 and B2 H2 be the base and height of triangle ABC and triangle PQR. So B1 is 9, H1 it is 5 and B2 it is 10, H2 it is 6. So we have that property, the ratio of areas of two triangles is equal to the ratio of product of base and corresponding height of those triangles. So you can write this ratio, area of triangle ABC upon area of triangle PQR equals to B1 into H1 divided by B2 into H2. So you can put the values 9 into 5, 10 into that 6. So therefore 45 upon 60. So 15 into 3, common multiple point of view. 45 you can write 15 into 3 and 60 means 15 into 4. 15 get cancels. What is the exact ratio? Area of triangle ABC divided by area of triangle PQR. So it is equals to 3 by 4. Now look into the equation second figure it is given. So just observation of that figure it is required. Given information is means in the given figure BC is perpendicular to that base AB in the first triangle. AD is perpendicular to that again AB in the second triangle. So now in that case this one question for 1 marks only. So don't draw the diagram in the answer sheet because for only 1 mark it is there. So we have to write answer only. So as we observe this given figure in the question paper, look into that base is common. That means these two triangles are right angle triangles. So if base is common, which one is the property? Triangles of equal base have areas proportional to their corresponding heights. So simply you can write from figure. Figure is not necessary in the answer sheet. So from the figure you can write area of triangle ABC upon area of triangle that ADB equals to height of first one it is BC and height of second one it is AD. So simply BC upon AD. So you can write in short that reason triangles of equal base. So you can put the values area of triangle ABC upon area of triangle ADB equals to 4 upon 8 because BC it is 4 and AD it is 8. So 4 upon 8 means it is 1 by 2. Next question as we consider look into that figure. Again all that information is given in the figure. So in the given figure that PS this one is perpendicular to RQ. That means this triangle PQR is obtuse angle triangle. Then for same triangle height and that base it is different. QT is perpendicular to PR. QT is the height but base it is PR. Triangle is same. So now as far as that values are given, if RQ equals to 6, PS equals to 6, PR equals to 12, then find QT. So if we observe that triangle, then in that case we have to calculate PR point of view that QT. PR means base and QT means height. So if we consider this triangle is basically obtuse angle triangle, you can calculate area. So area of triangle PQR equals to First of all, consider base, it is QR. So respective height, it is PS. So 1 by 2 QR into PS. So 1 by 2, 6 into 6, because value it is given. So 1 by 2, 6 means you can say 3, 6 as it is. So 3 into 6 means 18 unit square. Area of triangle, it is there. Now again we have to consider area of same triangle, but base and height we have to consider different. So now 1 by 2 base, it is PR. Now in the second case, that base, it is PR. What is the respective height? It is QT. So 1 by 2 PR into that QT. So therefore 18 equals to 1 by 2, 12 multiplied by QT. 12 means PR, which is the base, it is given. So 18 equals to 6 into QT. Transfer that 6 to the left, so 18 upon 6. That means you can write 18 upon 6 means 3. So QT equals to 3. Now the next, once again, here that given figure point of two lines are parallel to each other. It is given. In the given figure, AP is perpendicular to BC. AP is perpendicular to BC. AD is parallel to BC. This AD first line and that BC parallel to that. So as far as lines are parallel, you know, distance between that two parallel lines at any instant, it is same. So as we consider AP is the distance between that two parallel lines because it is perpendicular to BC. So height of these two triangles, it is same because these two triangles lie in the parallel lines with common base. So therefore we have to find this ratio, area of triangle ABC upon area of triangle BCD, or that ratio point of view, area of triangle ABC as to area of triangle BCD. So for that, once again, figure is not required. So AD is parallel to BC and AP is perpendicular to BC point of view. That ratio directly we can write with the base is common and height is also common. So you can consider that any one property. But after that, if we consider that ratio, area of triangle ABC upon area of triangle BCD, you can write BC upon BC. Which property we can use? Triangles of equal height. So triangles of equal height point of view, that you can write BC upon BC point of view 1 upon 1 because BC get cancelled. So this ratio, it is equals to 1:1 means 1 upon 1. So finally you can write area of triangle ABC as to area of triangle BCD equals to 1:1. Next one problem, we have to consider fifth one. Just observe the triangle. Look into that. In triangle ABC, that AD is perpendicular to BC and PBC point of PQ is perpendicular to that BC again. So in the given figure, as we consider the given information, PQ is perpendicular to BC, AD is also perpendicular to BC. So as far as that perpendiculars are concerned, base and height of respective triangles we have to consider. So find the following ratios. So for that, figure reading, it is important. So look into the ratios. So first one ratio, area of triangle PQB upon area of triangle PBC. So equals to BQ upon BC. So as we observe that PQB, look into that PQB. Now BQ is the base and PQ is the height. PBC. So BC is the base and PQ is the height. That means height, it is same. So what is the property we can use? Triangles of equal height have areas proportional to their corresponding bases. So what is the first one answer? BQ upon BC. BQ upon this total BC. What next? Second ratio. Area of triangle PBC and ABC. This total ABC. So you can consider, I think, that base, it is same. So as far as triangles of equal base have areas proportional to their corresponding heights. So what is the height of first one triangle PQ and the second triangle point of view AD. So PQ upon AD. Simple ratios are there. So just we have to observe the figure. Now again that next ratio we have to calculate. Area of triangle ABC upon area of triangle ADC. ABC. So BC is the base, AD is the height. Then ADC. DC is the base, AD is the height. So I think height, it is common. So triangles of equal height have areas proportional to their corresponding bases. So BC upon DC. In short reason, triangles of equal height. Last one, area of triangle ADC. ADC. And what about that next one? PQC. Triangle PQC. So as we observe the triangles, then ADC point of view, DC is the base, AD is the height. PQC point of view, QC is the base, PQ is the height. That means for both triangles, base DC and QC point of view different, AD and PQ point of view different. So we can use that first one property. Triangles are different base and height. If we consider that it is DC into AD upon QC multiplied by PQ. That means first property, it is the ratio of areas of two triangles is equals to the ratio of product of base and corresponding height. So in this way, in the first exercise, just these problems are important. Point of view that properties are concerned. Because that properties again we have to use in the next theorems also. So in the next theorem, important one, these properties we have to use. That means the important theorem is basic proportionality theorem. So that theorem point of view, these concepts we can use. So thank you.